Good morning, all. This is the VTU question bank for the engineering visualization subject. You can see that it is from the VTU. So we will move on to the development of lateral surface of solids. Okay. So we have completed the isometric. So you can see in the module 4, the first question is pentagonal prism of side dash mm and height dash mm has one of its faces parallel to the VP. It is cut by a plane perpendicular to VP and inclined at dash degree to HP, passing through the axis at a point dash above the PS, and draw the development of the lower portion of the solid. So first I'll be constructing an XY line here. We know that prisms will be constructed using parallel line method. So draw XY line. Okay. So go to polygon by center command. Select number of sides 5. Okay. Select thick line and here place it with the one of the sides has to parallel. So this is how we have to place. Now I am changing the dimension to 30. Okay. This is what the pentagonal prism resting with one of the edges parallel to VP. Okay. Now draw the 3 perpendicular bisectors to find out the center of it. Okay. Now give the namings here. So which is having both top face and the bottom face. So top face notations are A, B, C, D, and bottom face notations are A1, B1, C1, and D1, and that should be written within brackets. Okay, after writing the notations, we should draw the projection lines. So take 0.13 mm thickness line. So draw the projection lines. So axis length here will give the axis length as 60 mm. 60. So construct the front view. So we know that in the prism, the front view will be a rectangular face. Okay. Now it is cut by a plane perpendicular to VP, inclined at dash degree to HP, and passing through a axis at a point above the HP. So here, from the bottom face, I'll be considering a distance of some 30 mm, and here I'll be drawing an angle line. Okay, from the middle point of it. Okay. So here randomly we can choose the angle. I'll choose the angle 40 degree. And construct the cut plane, and then you can extend this cut plane so that it is showing where it will be cut. And now using this split command, you can split wherever you want to do the splitting. Okay, and then make that upper portion as thin, because this is what the cut retained portion we need to draw the development of it. So I'll be selecting that upper portion and making it as thin. Okay, now you can write down the notations for the cutted plane. You can check the angle. So the angle with respect to HPT is 40 degree. Now I can write the cut plane namings. So here it is 1 with respect to the vertical edge. No, it's not cutting there. Actually, cutting is happening exactly at the vertical edges. Okay, I think it's not happening in between. I'll recorrect it. Okay, exactly at BB1 we have the cut point 2 here. Okay, and the cut plane and exactly at CC1. Okay, 1 it is cutting at a vertical edge A1, and 2 is cutting at vertical edge BB1, and 3 it is cutting at the vertical edge CC1, and 4 it is cutting at the vertical edge DD1. Okay, and 5 it is cutting at the vertical edge E1. Okay, now draw a parallel line. So make that line continuous. Now I'll draw one vertical line here. Okay, using offset command, I'm going to offset it for 30 mm. Total 5 faces. Okay, because it is a pentagonal prism. Total 5 faces we have to consider. Total length we get it, that is 150. Can give the naming here: capital A, capital B, capital C, capital D, capital E, and capital A. Now we have to draw the projection from these cutted points. Okay, one it is cutting exactly at A, so that's why a straight line till it is cutting that vertical edge A here. 1 and 1 we can write it exactly here, and from that 2 also we have to, from that 5 it is cutting on the E edge. Okay, from the 2 it is cutting on the vertical edge B. Can write down to avoid the confusion. And from C you have to draw the projection line. It is cutting at C. And then from point number 4 you have to draw the projection line. It is cutting at D. Okay, and then from 5 also we have to draw an projection line that is cutting at E. Okay, now we have to join all these with the straight line. So I'll be drawing that vertical edges from 2, 3, 4 and 5. Okay, to indicate with the cutted portion. Okay, now we move on to the next problem. That is problem number 2 is a vertical chimney. Okay, of cross section dash mm, circular cross section, and located on the rooftop, sloping at a dash degree to the horizontal. Its the shortest distance of the chimney also dash mm. Determine the shape of the sheet metal area from which the chimney can be made. Use 1:10 scale. So vertical chimney means it is having circular cross section. So that means, so I'll be drawing a circle for a diameter of 50 mm here. First I will draw one horizontal line. We know that here this is also resembling to the cylinder. So first I will construct one simple eyes to demonstrate house here. Okay, above it I will be constructing a chimney so that you will get an idea how the problem has been demonstrated here. So this is what the chimney on a house, right? Chimney on a house. I can see that chimney having some slope distance and it is been inclined at some angle. right? So here I'll be assuming the dimensions and constructing it. So give the diameter 50. Okay, here for easier construction I'll be dividing this circle into only 4 equal parts, not into 8. So that will make the problem easier. Okay. Can write down namings for it. Now draw the projection lines to draw the front view. Here the height of the chimney also we don't know exactly how much length, but we have the height from the slope distance. Okay, that is from the cutted arc angle point. So randomly I'll take some length here. Okay, then after that we can join randomly. We will draw the front view. Then after that when we get the exact cut point, so we can change it. Okay. Now here you can see it has been rooftop sloping. We have to show with the angle with the horizontal here. Okay, so some angle we should consider with the horizontal to indicate that rooftop sloping. Okay, rooftop sloping a dash degree to the horizontal. Okay, we need to show that angle here. After getting that angle, we can show the shortest portion of the chimney from there for a height here. Okay. So now I'll go to the section plane, and from that one end I'll be drawing an angle line. Okay. Yes, from this end I'll consider angle plane. So go to angle and you can give the angle here. So 30-degree figure it will take like this. Okay. I'll take the angle here. I'll give some 135-degree. Okay. So this is what the angle line indicating the slope angle. Okay, slope angle here I think I have considered for. So and then slope distance shortest distance I'll consider here 30 mm. Okay, from this 30 mm, because they are not given any kind of dimensions in this problem, so I'm just assuming the distances, the dimensions here, and then constructing it. Okay, I think this problem I have did in the development of lateral surface of solids. So you can go to the playlist and you can see with respect to the dimension all, and this is the question bank problem. So just by assuming it, I am doing it. Okay, you can see the angle of inclination here I have given 45-degree. In the slope distance also you can show the slope distance I have considered 30 mm. Okay, now we have to draw the development for this. Okay, wherever the cutting has happened, we need to mention the cut points with the numericals. So here at the A it is 1. Okay, in the same way at vertical edge B we have 2. And then vertical edge 3 we have, at the vertical edge 3 we have C. And at the D we have 4. Okay. Now draw an parallel line here. Yes, from this end you can draw a parallel line. Okay, consider one vertical edge here. From here the distance we should consider, that is pi d. Okay, so using pi d formula you can find out pi value, and diameter it is 50 mm. So if you do, you will get 157 mm. So using the calculator you can find out the distance 157 mm. Okay, now we can divide this 157 into 4 equal parts. That is 157 divided by 4 I can give, you can see there in the offset command itself. Okay, 157, because it is having 4 equal parts. 157 divided by 4. So we'll get here 39.25. So it is equally divided into 4 equal parts. Okay, now draw the projection line from these cutted points here. So before that, I'll be mentioning these vertical edges with the capital letters. So this one, it is cutting at the vertical edge here. That's why it is extended till there. And then from point 2 and 4, it has been cutting. 2, it is cutting on the vertical edge of B, and we can extend it till D also, because 2 and 4 are on the same point. So this is our point number 2, and 3 exactly lying on the point C at the bottom end. Okay, we can extend this in order to show the number 4 here. Okay. Okay, this is a circular portion, so I will be going with the curve command here. So joining from 1 to 2, and from 1 to 2, 2 to 3 we should go, and then from 3 to 4, and then 4 to 1. This is where cutting is happening. So I'll draw another line here to indicate the top portion. You can see that I'm indicating till here it has been cutted. Okay, this is what the cut upper portion. So you can show the thick line here also. Okay, so that completes the problem. We'll move on to the next problem. The next problem, it is a cone problem. A cone of base diameter dash mm diameter and height dash mm rests with its base on the HP. A section plane perpendicular to VP inclined at dash degree to the HP. Bisect the axis of the cone. Bisects means it exactly the middle point of the axis. Okay, bisect the axis of the cone. Draw the development. So here you draw an XY line here, or a smaller line also possible, because this is not drawn with the parallel line method. This is having slanted line we should consider here. I'll consider the diameter 50 mm for the cone. Base of the cone is a circle, so it is drawn with the diameter 50, and here again I am dividing this circle into 4 equal parts. Okay, so by doing 4 equal parts it is easy, and we can construct it easily. For 8 parts means it will take a little bit of more time. So if you want, you can do it with the 8 parts also. So for you people to understand, I am showing with only the 4 parts. So write down the namings. Okay, draw the projection lines upward to complete the front view. Axis length here I'll be considering 60 mm. Axis height of 60. Show the dimensions. Okay, so this is drawn with the slant edge length, so we don't require a parallel line here. Okay, so you can show that slant edge length, that is capital R, 65 mm. Okay, you can mention capital R slant edge, capital R is equal to, you can mention R is equal to 65 mm. Okay, and small r, that is radius it is 25. To find out the development of this, we have the formula. Okay, that is small r by capital R into 360 degree. So that's how we can able to find out the development area of the cone. Okay, remember it, small r by capital R into 360 degree. Okay, into 360 degree. So using the calculator, if you find out, so you can use the calculator here to find out how much the angle it is. The angle we are getting, that is 138 degree. Okay, 138 degrees. So first we have to draw one vertical line or horizontal line, whichever it is, for a length of 65 mm, that is capital R, we have to draw 65, and then go to arc by center, select this 65 mm and give the angle, that is 138 degree. Okay, you have to give the angle here. Okay, the radius length it is fixed, that is 65, and here angle you have to give angle, that is 138 degree. Okay, you can give the angle. Okay, this is what the development of it. So select this portion and keep it properly in a space so that you can able to see it properly. Okay, making a copy and moving it. So just I'll delete that one part. Okay, this is what the development of it, but we need to show with the cut plane here. So you can show the dimensions and the angle, no problem, but we need to show with the angle line here. This is what you can say the basic problem, but you can see here we have to show with the cut plane. A section plane perpendicular to VP inclined at dash degree to the HP bisects the axis of the cone. Bisect means it is exactly the midpoint we should consider. Okay, so midpoint, you can see this is how you can find out. This is what the midpoint symbol, and here we can have to take the angle. So here the angle consider, that is 45 degree. 45 degree angle. Go to extend to next. Okay, now we can show the angle and we can able to development, and again you have to find out the development of the truncated cone, that is the lower portion of it we have to find out. Okay, with the help of split command, I'm going to split it to find out the exact points here. Okay, make those lines as thin lines, 0.13. okay, can mention 1 2 3 here, but we should project these 1 2 3 points. Okay, 1 2 3 4 points on the slanted length. We have the slanted length of 65 here. Okay, we have to project all these points here. That's what I'm going to do it. Okay, from here horizontally draw to the this slanted length. Okay, can just project it, and this is 1 and this is 1 on the slanted, and this is 2. Okay, and this is 2 and 3 we having it here, and 4 we are having it here. So we can measure the dimensions here from that exact apex point to here, that is 55.71. Then from that again that apex point to the point number 2, can measure the dimension. That exact length we should measure using distance between 2 points. So you can change that using distance between, command is there, right? You can change that option here, and then you can able to measure it to the exact points. Okay, this is what the dimensions we get: 55.71, 32.5, 22.94. So for now, first we have to divide this arc area, that is cone area, into 4 equal parts. Okay, so to divide this into 4 equal parts, so we will go to the, we have to use the arc by center command. Okay, arc by center command, we can do it. So here in solidity4, we cannot able to divide that area using that angle command. That means we should go to the arc by center command only. First I will take that 65 mm length and cut 2 arcs exactly at the middle, 65, and cut it. From that extreme point, okay, end point, you have to consider that 65 mm length you should consider. So cut 2 arcs and join this, get the exact point here, center point. So from this center point we can draw a line, straight line, connecting it. So now it is divided into 2 equal parts. Okay, the same way from that exact point, so you can consider any length. Again, from that 2 extreme points, we should consider the length and cutting the arc, so that we can divide these 2 equal parts into 4 equal parts. Okay, yes, from this extreme point you can consider any length. Okay, here I'll consider 50. So cut the arc. The same way you can do it on the other side also. Consider 50 mm. Cut the arc. Again, from that extreme point, you consider the radius 50 and cut the arc. Okay, here also you can consider radius of 50 and cut the arc. Can extend these 2 arcs. Yes, now you can see that clearly. Now you can join these points with a straight line to that point here, so that it will be divided into exactly 4 equal parts here. Okay, now we are going to trim it out, the extra lines here. And we can mention the namings here, mention with capital A, capital B, capital C, capital D, and capital A. Okay, the first length we should consider on vertical edge here, it is 55.71. okay, to get that exact point number 1, so go to arc by center. can consider a radius of 55.71. Enter and cut the arc. Okay, the same way you can do it on a vertical edge of A, 55.71. Enter. Okay, this is what your points 1 here. Now on the vertical edge D we have point number 4. Point number 4 and point number 2 are same length. I'll consider 32.5 what it is there. Cut the arc, and the same way you can do it on the vertical edge B here, 32.5. Cut the arc. Now on the vertical edge C you need to cut it for 22.94. So give the radius. Okay, cut it. Now I can write the naming for it. So this is 1, this is 2, this is 3, and this is 4, and this is we have 1. Now connect this all these points using curve command here, because this is an cone here. So go to arc and go to curve command and connect all these points. Okay, go to curve command here. Okay, subscribe for the channel and hit on the bell icon for the latest notifications, and share it to the maximum students so that they can be benefited from this. So if you like the video, you can support like this channel for your contributions, and share it to the maximum students so that they can be benefited from this. Okay, so this completes the problem. Thank you for watching the video. Subscribe for the channel, hit on the bell icon for the latest notifications, and share it to the maximum students.